Good morning, good evening, good afternoon. Welcome. And we are joined here today on a wonderful Open Source Friday with Shreya, the founder and CEO of Guardrails AI, and here to talk through a little bit around what it takes to build responsible and ethical AI around tooling and eval. So, Shreya, welcome to the show. We're excited to have you today.
Yeah, thank you for inviting me, Kevin. I'm really excited to be here.
Well, it's a wonderful day for me as well. I mean, I think it's one of the unique opportunities to spotlight companies also that we've invested in through the GitHub Fund and just kind of accelerating these communities in open source. So we're excited. Maybe just to kind of kick off a little bit to the viewers of the show, would love to have you do an introduction to yourself, your background, kind of how you came to Guardrails AI, and how you thought about the open source ecosystem around this platform that you're building, and maybe even just give a little bit around what you do as well at Guardrails.
Yeah, absolutely. So I'm Shreya. I'm one of the co-founders and the CEO of Guardrails AI. Before starting Guardrails, my background is in AI and machine learning. So I've been working in AI ML for I think like 12 or 13 years now. Started out doing a lot of research in classical AI and publishing, and then worked on self-driving cars, doing a lot of like what I'd learned, and applying it to like the most complex, sophisticated agents, I guess, that were like actually operating on the real roads. And then, from that kind of like worked in AI infrastructure and then spun up my own company, really kind of inspired from just how challenging it is to bring AI to production and what are all of the, massive amounts of infrastructure we need to kind of make it work very reliably. So that's kind of like the purpose of Guardrails, which is really to think about like not just like building AI-enabled software, but how do we make AI-enabled software work with the level of reliability that we're used to for traditional deterministic software, right? So the many nines of reliability. So that was kind of condensed history, but I think it's very nice to see just AI become mainstream, and a lot of the lessons kind of like that I learned along the way, seeing adopted as mainstream is really nice to have. Yeah.
That's a great background. I think even just being in AI for such a period of time, and now being in the evolution of where we're at today, I'm curious, what was the aha moment that you saw that really said, "Oh, I need to go build a product and a solution in this capacity," and
Mhm.
what catalyzed you to start working on Guardrails specifically from that?
Yeah. I think like I think it was all after ChatGPT. So as for a lot of people, I think like AI pre ChatGPT and post ChatGPT, feels very different because like I think there's a very fundamental shift from like models to systems that use models as any computing, right? And that suddenly kind of widened the aperture. So doing AI changed from like, okay, I'm collecting my own data, I'm running a lot of like training loops, etc., and doing a lot of like testing, to I'm basically just writing prompts and I'm thinking about how to glue these different pieces of AI components together. So I think that shift was pretty substantial, and it meant that a lot of the ways that we knew how to do machine learning and how to test it won't really work in the new regime. I think the other kind of key insight I had was that the only real parallel we had with like how new age AI systems are built, using generative AI, is weirdly, surprisingly self-driving cars or robotics, where you essentially have these like multiple kind of machine learning models that all kind of stack together, are called in a loop, and then you care about like end-to-end latency, even compared to like previous let's say text-based ML work. It would all be about like training the best model you can rather than about building the system. So I think like I think I had that experience that allowed me to kind of see that very early on into the ChatGPT kind of like explosion, that the work would shift from like it's very easy to now build a system, but making it work very reliably is going to be really challenging, and it's actually going to be require huge amounts of infrastructure monitoring, internal ML capabilities, and that we don't need to do all of this work from scratch. We can really look to see how these problems were solved in self-driving with a 10-year head start and a near infinite budget, and then take a lot of those techniques and apply them to AI systems. So that kind of catalyzed it.
That makes sense. And maybe, just double clicking on that a little bit is like,
Mm.
what are you actually solving with Guardrails? Like what are the things that you're bringing to the developer ecosystem? What types of tools, and what do the developers actually benefit by using Guardrails?
Yeah. So I think the kind of purpose of guardrails is, again, reliability infrastructure. So throughout the life cycle of, development, training, testing, and post-production, making sure that you have all of the infrastructure that you need to make your AI system work very reliably. So we got to start, and we're probably best known for our open source framework called Guardrails, which was, I think at the time, like very, very early into the market. And since then,
Hmm.
Guardrails has become like well understood as a piece of infrastructure that you need. And what the open source guardrails, or guardrails as infrastructure really does is it explicitly verifies any assumptions that you make of your AI system, and it does this, in a live online setting in production. So the idea is, if you think about, let's say, any deterministic software or any AI system, right? The kind of space of what like your, I don't know, like deterministic software, what your website can kind of like produce is so limited that you don't need to constantly need another model to kind of verify it, right? But that's not the
Yeah.
case in AI systems. In AI systems, you do need explicit verification. Let's say you're assuming, you're, for example, like generating JSON for your agent from your model, right?
Hmm.
Even with all of the prompt engineering that you're going to do, a lot of times you're not going to get JSON that actually feels or looks valid. So you need to explicitly verify, is this something that actually works? Or hallucinations, is my model hallucinating? Is my model, getting jailbroken easily and giving out like really harmful information? So you need to explicitly verify all of the assumptions that you kind of make. So that was what we started the company with, what we're best known for. And then since then, we've kind of moved, like earlier in the developer lifecycle, which is basically building like simulation environments that allow you to test out how your system behaves under a lot of large scale user simulations coming in and interacting with the system, so that you can anticipate where your system will break before your users in production actually break your system.
Super interesting. And then I guess like with learning how to break systems, like what are the feedback loops that developers look for within this, and like how has that kind of helped you learn what to build and ship within the product itself?
Yeah, that's a really great question. I think one of the most interesting learnings I had was that, I guess, like coming from an ML background, that a lot of the people that are now building AI systems tend to, like not have that AI background and tend to kind of like approach building an AI system or an AI agent like building traditional software. So you just kind of string together a few APIs and, it kind of like works end to end. But I think like very often they discover that, that by itself is insufficient. So I think like
Mm.
the developer loops, might be newer for, I guess, software engineers, but very bread and butter for, people with AI ML backgrounds, which is, like a constant kind of like I guess extensive testing to kind of like understand how your system actually performs. So that involves like, first kind of like even outlining a rubric of what you really care about, what good looks like or what bad looks like, and defining that is actually pretty challenging. So doing that, once you have that, then creating a data set, and then actively monitoring it, and continuing to like test against the data set rather than test in just like end-to-end functionality. The more diverse, the more coverage your data set has, the better you're going to be. Developing in a way that allows you to account for the uncertainty of the model itself is like key to the success of how well adopted your system is going to be. And Copilot is a great example of that, right? It was the first UX that really cracked how to deal with the model uncertainty, and that led to the wide adoption of Copilot, and just kind of changed the trajectory of software development. So I think like those are some of the kind of like practices that like we see developers kind of like adopting, that they become successful with.
Very cool. And maybe double clicking a little bit, like what type of applications are you seeing developers utilize guardrails for today? And, are there any learnings or insights that you've seen kind of in the evolution of what you've built so far on where they're building new applications?
Oh yeah, I think it's I think 2 years feels like a very short time, but even in that, like so much has changed. I think like guardrails started out from a very application centric lens,
Mm.
and then we I think like and it's kind of like a fundamentally new technology that wasn't needed pre Gen AI, right? So I think initially
Right.
a lot of people were just trying to understand it, and then I think starting last year we started seeing guardrails being adopted less so on a specific application level at that time, and more so like organizations or platform teams were building their AI platforms. So if you're working as part of any company, you would use, the AI infrastructure from a platform rather than like, in a very decentralized way, signing up for, OpenAI access. And then as part of doing that, then you would, need like guardrails in and around the centralized platform, making sure that, nobody on your team is leaking PII or, using LMs in a way that doesn't adhere to company policy. So we started seeing a lot of that starting last year, and then like cut to this year again, where agents, I feel like, have finally become feasible in a way that they weren't for the past couple of years. So I think with agents, then you go back to needing guardrails on the application level and making sure your agent, doesn't get stuck in weird loops, is constantly aligned with what the user actually asked for, is not trying to make requests that can be unsafe, etc. So I think that kind of like going from guardrails on simple applications to guardrails on platforms to guardrails on agents is kind of the trajectory that we've seen.
That makes sense. I'm going to actually pull up a question from the crowd because I think it was a good one. Would love to hear your views on using different models to check hallucinations. Like, what a great question to dive into, and how do you think about it with guardrails specifically?
Yeah, it's a great question. I think in general, even like zooming out from guardrails specifically, like I think we build a lot of AI agents, etc. And like the way that we've seen a lot of the success is using multiple models. So, having like relying on both open source proprietary models, even like sometimes for the same task, and then kind of like switching between them or routing between them ends up being like a pretty successful pattern. I think not just for uptime or reliability reasons, even though that's a very kind of foundational requirement that I think the models haven't quite solved yet. But even outside of that, just for even like optimizing accuracy or cost or latency, etc., like having these multiple models is with a lot of trial and error, we've kind of like, converged on that. I think for guardrails specifically, and for the use case of checking hallucinations, I think there's a lot of advantages in using multiple models because you can kind of like stack them in this like kind of waterfall way, right? So some hallucinations are, there's like all of these like, there's a whole taxonomy of hallucinations for which there's a bunch of papers that I'm happy to share offline. And the idea is that hallucinations can be like with context, where you have maybe some like knowledge base and your system is hallucinating, for content that's present in the knowledge base, or, context-free hallucinations, just about like news in the world and hallucinating about what happened there. And depending on like what kind of hallucination is, it might be like harder or easier to check. So what you can do is like for simple, like let's say numeric hallucinations, you can basically have like simple lookup type models, right? Which are very, very cheap, but don't flex to like all of the different kinds of hallucinations you can have. And then you can kind of start out with, like maybe more complex models, let's say a llama model that's fine-tuned just to kind of check for factuality. And then, for like very, very challenging tasks, basically maybe look at like even reasoning models, right? And there's a constant trade-off here between just how powerful the model is and how much latency it introduces. So it really varies from development use cases, and then you can kind of like stack them in this like multiple model setting to kind of get the exact recipe that you want for latency and performance. Yeah.
I like calling it a recipe. I think that's right. It's a variety of ingredients that bring together the best experience overall. I'm going to surface another question that came up that's kind of interesting. Responsible AI is often easy to build in a pilot, but hard to scale. And like, how are you thinking, or what do you see with technical or governance challenges and implementation at large companies? That's actually a really interesting question.
Yeah, it's a really great question. I think we've kind of like seen this a lot. To be very candid, I think like guardrails are one part of the responsible AI framework, and I think like the most kind of like well-defined or successful responsible AI programs within especially large organizations tend to have like a very a very diverse set of like recommendations based on what you're doing. So your responsible AI like recommendations for if you're just using, let's say, an internal LLM for employee productivity or a co-pilot in some settings should look different from, if you're building a, let's say, HR support chatbot that's internal facing only, and that'll require different guardrails and different set of just like checks before it can be productionized, versus something that's going to be customer facing needs like something totally different, right? So I think an organization that recognizes that and then has a program to, that's equipped to deal with all of the different ways that AI is going to be entering like our work, just our work processes. I think that's kind of like the foundational thing. And then outside of that, like what we really kind of recommend is that guardrails, there's no set of recommended guardrails if you don't take into account context of like what is the application or system that's going to be used.
Mm.
So there's a bunch of like really great frameworks like NIST, AI, RMF, OWASP, top 10 for LMs, and not every recommendation in that translates to a guardrail, but like for OWASP top 10, 7 out of the 10 like typically do. So if you're going to be building something that's external customer facing, then relying on OWASP is probably a good idea, but it's kind of like the baseline, but it's insufficient because you also need to care about a lot of like company alignment guardrails, etc. So I guess like my answer is like in terms of the specific guardrails that you need, it really does vary, but being very thoughtful about security, product alignment, company brand alignment, risk, etc. is kind of like the principle, and then based on that you can pick and choose which guardrails you really want. Yeah.
That's super helpful. And I guess like double clicking a little bit, since it is kind of you know consumer reliant on how they build the application, do you do enablement or training for folks that are trying to build these applications on how to best design their own evaluations, or like how do they think about the right ways to implement this for their own systems? Because that's actually like the secret sauce, I guess, of building it is that.
Yeah, absolutely. I think guardrails can be very daunting for people because you I guess on a very like instinctive level, people understand that you need them, and because they understand the risk of hallucination and they've encountered it. But it's very hard to know which ones you truly need, right? Like for example, I'll actually show this in the demo later on, but we have a hub of open source guardrails that we created, which we built a bunch of them, and then our community contributed a bunch, and it ended up becoming like a very large collection. It's 70 guardrails today and counting, right? And you would think that like, okay, this is great, and I now have like all of the guardrails I can kind of want. But then is the idea, like, let's say you're building something that's going to be customer facing, is the idea that you just take all of that and add all of those guardrails to your application, and then you run that, and is that the best way to do it? And like what we kind of like do as an organization is first kind of like help you come up with a program about like what are the actual true vulnerabilities of your system, and being very like intentional about that, and not just kind of throwing the kitchen sink at it.
Mhm.
And then the second thing is we kind of like encountered this problem so much that we actually ended up building the second product that we launched, which is called Snow Globe, which what that does is it answers the question of like, what guardrails do I need, right? And how we do that is like we built a simulation environment where you connect your AI like chatbot, and then we simulate a lot of your eventual users coming to your system and interacting with your chatbot, right? But we do
Super
it
cool.
programmatically and at scale. And because we do it at scale, you can essentially understand where your risks and failures are, and then only add those guardrails that you really need.
That's super helpful. Maybe shifting just a little bit, I'd be curious. There's a couple questions in here. Maybe I'll spotlight this one, but someone that's just starting out with AI, building agents. I would say like guardrails is actually, one of those things where people should be thinking about earlier in their development life cycle. But like, how do you think about it in someone's journey in AI?
I actually, Kevin, I might disagree with you here.
Okay.
So I will say, I think if you're an organization and you're thinking about how to, make your organization AI enabled, then you need to start thinking about guardrails very early on, because otherwise, you're probably opening yourself up to some liability. So if you're an organization, 100% yes. If you are building not an organization, not thinking about this very foundationally, but thinking about this more on the application level, then I would say like knowing where your guardrails will kind of slot in is probably good enough to start with. And then once you have your end-to-end system built, you have like some pipe flush done, then be very intentional about guardrails, and only add the guardrails that you really need. There's some frameworks that, depending on your audience, you should really add, but honestly, like test it in a lot of different ways. Maybe you don't always need toxicity guardrails, because that's not actually a real risk that your system has, even if OWASP top 10, or other frameworks say it might be a risk, right? So only add the things that are actually likely to go wrong in your system, because there's always like a latency versus like performance trade-off there. In terms of resources, I think there's a bunch of great ones. One that I'll kind of like do a selfish plug on here is the Deep Learning AI course series that Andrew Ng created. So I created a course for them as well on guardrails, and it was really about we assume that you build like a simple RAG chatbot, and then how do you think about like adding guardrails there? How do you test if they work, etc. So I'd recommend that as a good starting point. Yeah.
Super helpful. And maybe for folks, actually, this would be an interesting one too. Like, do you think about net new developers in AI contributing to your open source platform? Like, how can they get involved with that a little bit?
Yeah, absolutely. So we kind of like designed our system to be very modular, so it's designed as like a one-two part system where the first part is just orchestration of all guardrails. So they run in parallel, they run with very low latency, they can scale, etc., and they can be easily configured. And then the second part is just like a collection of which actual guardrails you want to run in your system, right? So the second part's
Mhm.
more like a hub, and the first is, like just running all of it together. So the easiest way to kind of do this is that if you're kind of like building anything, any guardrails for specific use cases, etc., you can basically contribute those back to our hub, and you'll be in great company with a bunch of other like really great individuals and companies kind of like contributing their own guardrails. So that's, I would say, something that's open source, but not your standard, check out our open issues and
Sure.
contribute there. But you can also do that. Check out our open issues and contribute there. And then we have a Discord community that we kind of discuss just AI reliability things on. So yeah, that would be another great one to be part of. Yeah.
That's awesome. And maybe shifting just a little bit from that, like, what do you think about the roadmap for guardrails right now? Like, where do you see that going with the world of agents? Any new exciting features or collaborations or research that you guys are focusing on?
Yeah, I think like for us, a lot of our work is on like model research. So we
Hmm,
continue,
interesting.
and there was also a lot of what the question was about you checking hallucination with different models, etc. So I think we a couple of months ago launched the first ever kind of like index or benchmark of guardrails, where we kind of created a data set of, created or curated a data set for 6 of the most common categories that we saw for guardrails. And then on top of that, we benchmark like our guardrails, other guardrails, etc. And then, we kind of like told you what the expected latency versus expected performance on these data sets were. So I think a lot of our work is on, making the models that you're actually kind of running the guardrails with better. And that's kind of like a big part of the roadmap. And then just kind of like continuing to do like public benchmarks, etc., around there. Yeah.
That's great. I maybe would be remit to ask this, but how do you stay on top of all the new model releases? Like, how do you continuously benchmark
Yeah.
and ensure your tools are ready for those?
Yeah, I get asked this question a lot. I think I actually tweeted about this recently. I think like maybe like not a very popular answer, but honestly, Twitter is great for keeping up with model releases. I know
Sure.
Twitter or X now. I think like it's unpopular because it's obviously like distracting and stuff. But I ended up creating a list of people that I think are very high signal and talk about both like foundational AI research, application AI, announcements, model announcements, etc. And so I will share a link to that as well. But I think like it's basically curating a feed of people that tend to talk about like models, AI news in a very holistic way. I think it's honestly like how I keep up with it. So
Yeah, I mean it's a great resource. You should definitely drop it in the chat. And maybe but before we jump in the demos, I have one more question, which is like, the balance of vibe coding as an experience with AI tools versus like more complex AI models. Like, how do you think about that within the construct of guardrails itself?
yeah, yeah, I guess I do mean like what guardrails are I guess relevant for vibe coding applications versus what guardrails are, like other applications, like comparing those two.
Hmm.
Yeah,
Yeah.
yeah, I think for vibe coding, this is actually a great kind of demonstration of what I was talking about earlier, which is like guardrails are so context and domain independent. I think for vibe coding, like you probably don't care about a lot of like hallucination style of failures there, right? It's more about like, am I writing unsafe code? Am I exposing some
Right.
secrets that I shouldn't be exposing? Or are there any kind of like code level vulnerabilities or injection attacks that I may be introducing into my code, right? Or maybe like, am I writing code that's like incongruent with my dependency, what my dependencies look like, or maybe just like version updates, etc. So that's probably the most helpful checks, etc., that you can do compared to guardrails for, let's say, chat interact, like customer service for a large bank, where your set of concerns is going to end up looking pretty different. So I think like that's just like which guardrails to pick. That's kind of like a
Sure.
few things I'd highlight. I think the other kind of like thing to think about here is also like when should you apply guardrails. I think with vibe coding, you kind of need to balance out like when do the risks actually get introduced into the system, right? So thinking about guardrails, like not at like typically guardrails run at every LM invocation, right? Like every LM call that you make, you'll have like some input guardrails and some output guardrails that will verify the inputs and outputs of your system. If instead of doing that, you think of like guardrails, more at like, okay, when I'm committing the code that I vibe coded, etc., that's probably a better way to think about it, because there's so many kind of like mini LM invocations that will really slow down the overall experience if you add them at the LM invocation level for vibe coding.
That makes sense. That makes sense. Maybe shifting now, let's jump into the demos. I think it's a good opportunity for folks to get an overview of the platform and see both the products that you have.
Yeah, absolutely. So I'll start out with a demo of Guardrails. And I know this is supposed to be a live demo, but I'm just going to share one single slide for just to kind of like make sure that, I'm kind of talking about that we're all kind of like aligned on, what it's just like how the architecture kind of like works and stuff.
Mhm.
So,
That sounds great. I think people will really like it.
okay, awesome. So this is
Cool.
the only slide that I'll show about guardrails, and it's a very high level kind of idea about like what guardrails are, where they fit into your system. So again, if you're thinking about any LLM application, right? Like you might have at the very core of it, the idea of an LM application is you have like some sort of prompt, and you can add as much context you want into this, and this becomes like maybe like context engineering is something that's very popular and discussed recently. So that this will turn into that, and this prompt then feeds into your LLM. Your LM kind of, again, could be anything, does the processing, etc., and then returns an output. And this output is used in various ways, right? Like this could be a JSON if you're building an agent. It could be, let's say, just like your like unstructured text that you then pass into, like some sort of like writing agent, etc. But at the core of like every LM application is the structure, and you can like add multiples of this, mix and match this in like weird ways if you want, right? The core idea of Guardrails is that any request that you send to the LLM and any output that you get back from the LLM should be explicitly verified. And this verification can be for types of checks that are, once again, like relevant to what you care about and what you're building. So before
Mhm.
you send out your prompt from your context out into the LLM and it crosses like network boundaries, maybe you want to check that there's no PII that you're going to be like leaking or being on the hook for. No other company proprietary information, no jailbreak attempts that you're kind of passing over to the LLM, and the LLM is going to be jailbroken, right? So these are things that you explicitly kind of like check for and validate. On the output side, before you use the output that your LLM generated directly within your code, maybe you want to check to see that there's no hallucinations before you put it in front of your customers, or there's no like NSFW topics or sensitive topics, etc., that you're passing in directly in front of your users, etc., or using downstream in your application. So that's kind of like the core idea of like how guardrails are.
I love it.
And
Before you jump off this, I mean, you've talked a little bit around the balance of performance, latency, and then quality kind of coming through this. Like, how do you think about really high throughput, performance, scalable systems in this respect? Like, obviously, you need to have these, especially at the enterprise level. But yeah, how do you think about those trade-offs?
yeah, I think like I think it is very hard to be prescriptive about this, because like for some, for example, for PII, we often find that like, okay, it doesn't matter how much latency. I mean, it kind of does matter, but like it's worth the latency hit to make sure that we're
Mhm.
absolutely not leaking any PII, because that's how business critical it is, right? For some other things, such as like benign hallucinations, etc., maybe it's okay, right? Maybe you don't want to introduce like a 1 second latency to make sure that you have no hallucinations, because like that isn't as worth it as like maybe just letting your customer or your final user kind of like deal with the kind of the eventual latency hit. So I
Right.
think it is really kind of context dependent. The one thing I will say is like you can build these systems in a way so that they tend to be very low latency, So for example, things you can do is like, for start, make sure that you're not using too many LLM as a judge style guardrails, and you're more using like rules-based system, or like fine-tuned ML AI models, and those tend to be much lower latency and also kind of like much more predictable performance. The other things you can do is like run all of these in parallel, run guardrails in a streaming setting, so that you're kind of like streaming large inputs into your guardrail and then generating outputs streamed out as you kind of go. And there are like a bunch of orchestration challenges around this, which is also what our open source framework that then handles.
That makes sense. Yeah, it seems, to your point there, having parallel process and then really thinking about, more orchestrative systems that people may not think through at the onset of like, oh, this is how I could make this a little bit better, more reliable. So super, super helpful. Yeah, I would love to like dive in then from here to the demo.
Yeah, absolutely. So what I'm going to show before I kind of go on to the demo is actually our open source Guardrails hub. And so the idea behind this hub is, if any of you are familiar with the Hugging Face model hub, it was, like very inspired from that, but for guardrails. And the idea is that, you can kind of like use any guardrail that you want for different kinds of use cases created by us, other companies, etc., to kind of make sure that you, get only the guardrail that you want, because once again, there's no free lunch. Every time you add a guardrail to your system, you are introducing some latency, right? And the expectation is that that latency, like the value that you get from that latency will kind of be worth the extra latency hit that you get. So for example, like there's a guardrail that I'm kind of showing you for, ensuring that your LLM is generating the exact correct language, because anytime you're building something that, uses a model, but is working in a low resource language setting, you'll find that even if you ask your questions in that local language, like a lot of times the LLM will respond in English, right? So you want to, if you're especially working in these low resource language settings, you want to ensure that you're always adhering to the language that the customer asked the question in. So, you can have a guardrail for that. You can have, like Llama Guard, which is your classic AI safety, no violence, no hate, no criminal planning, no sexual content, etc., kind of like checks. So that's another guardrail you can have, but you might not need. So let's say, for example, you're building like a, vibe coding agent. You probably don't need, Llama Guard. You more so need, like other, much more like code specific ways. So we basically build this hub. You can kind of like figure out what kind of your use cases. Let's say you care about code gen. These are probably the guardrails you want to even like start looking at, and then you can kind of go through each of them and then pick and choose the ones you want. And then obviously, if you want to create your own guardrails, that's kind of something we support. And then what I'm going to show you after is basically a kind of like demo walkthrough in a Jupyter notebook. That essentially shows you, what the process of like maybe creating your own guard or using a guardrail looks like, and just what the process of like validating those requests look like. So essentially, what this essentially looks like is,
maybe zoom in a little bit if you can, just so that people can see the. There we go. Perfect. There.
Oh, sorry about that. Okay, is this good or?
Yeah, I think that looks great. I think we can see it now.
Okay, awesome. Yeah. So essentially, what I want to kind of sorry, what I want to show you guys is the process of what we call creating a guard. And a guard is, once again, in the diagram that I was showing you, it was the collection of guardrails that runs on an input or output setting, and it basically is only the set of guardrails that are relevant to what you care about. Sorry, just 1 second. So in this case, what we're kind of going to do is basically kind of create a guard that essentially looks for, like the kind of like custom guardrails that, that we kind of put around the request that for the LLM that you're kind of sending over. And then in this case, we basically make sure that we're validating every single request that we kind of, pass through the system. And then we also kind of like fix that request before we kind of send it over. So I'll show you a couple of guards that we kind of create here. So the first is this like LLM kind of profanity guard. And in order to kind of like create this profanity guard, like we basically just pick and choose the validator that I was showing you from the hub that we created for profanity free, right? So once again, it's like a few lines of code to like basically fetch the guard from the hub, and then, fetch the guardrail from the hub and then add it to the guard that you kind of care about. And then suddenly you end up kind of like getting this getting this guard that you get an ID for, you basically kind of like get a whole schema for, and you can add it to your platform or to your AI agent or your chatbot, and make sure every input request or output request basically has no profanity. And then I'll kind of like
And something like that, like, is that easily customizable for the user, or is it off the shelf enough that they feel like, it's going to do a good job blocking profanity? Because I actually think a previous journey implementing some of these, like, there's quite a bit of customization or like input you might need into some of these as well. So
yeah. I think that's generally true. I think like there's like broadly two classes of guardrails. I would say like a lot of things like profanity free or even jailbreaking, etc. It
Mhm.
is somewhat or like hallucinations, right? It is somewhat of a common denominator. So you can build these like generalizable guardrails for it, and that's typically what we tend to have on the hub. And then
Right.
for a lot of other use cases, you do need a lot of like hyper organization, context specific guardrails that only you can create. So then our kind of like philosophy there is like we provide and we equip you with like all of the tools that you really need to do that.
That makes sense. That's awesome.
Yeah. Yeah. And then for this one specifically, this is one of the ones that, is like pretty common denominator. So you can just like make it like use it off the shelf essentially. Yeah.
Mhm.
Okay, so we basically created this guard. In this case, I didn't like create the guardrail myself. I just picked the one from the hub that I was kind of showing you earlier. And then once I kind of created this guard, I can basically like validate it. But like, so this is the text that I'm validating with pretty benign profanity, if I
Yeah.
might say so. But I want to keep it, like safe for word. But essentially, you have like any text with profanity in it, you essentially get like validation failed, and then you can basically like also get a detail of like why validation failed, and then you can basically like use this to clean out or fix the text that has profanity in it, so that you're always returning like sanitized versions of the text, or only sending
Cool.
sanitized versions of the text. Or you can do like other kind of like re-ask the LM to generate something without profanity, or maybe raise an error for your user that they shouldn't use profanity here, etc. This other one that I'm going to show you is like basically a sentence that kind of like doesn't have that, and then it's the same thing. You basically get like a validation success, so your validation passed, and then you're kind of like free to go as you free to pass that text with. So going back to that diagram that I was showing you earlier, so it's basically an optional check, right? Only when something is bad does it kind of flag. Otherwise, it's just
Mhm.
business as usual, and it feels like almost invisible to your organization.
We have a question real quick that I'd love to maybe dovetail to this, is how does it work under the hood? Do you have a large data set of like checks against this, or are you doing anything else to kind of like validate? Like what does the actual canonical library look like, I guess?
Yeah, that's a good question. I think for each guardrail, like there's basically three classes that we have. Like one is rule-based systems, so that'll be like regex checks, or there'll be like a set of like it's like kind of a combination of what we do here as well, where you have like just a kind of corpus of like bad words, etc., and then you basically kind of check against that. But it's more kind of like, let's say like deterministic code. The
Mhm.
second most common category is fine-tuned machine learning model. So we'll pick up like a small model, right? Like maybe a Llama 7, 7B, or like even something smaller, like maybe a BERT model or something, and then fine
Mhm.
tune it only as a classifier that classifies like, is any PII, is any hallucination, is any profanity present in it. And they tend to have like, I would say, the most accuracy latency trade-off. Like they're still pretty fast,
Interesting.
but kind of expand more. And then the third kind of under the hood like implementation is LM as a judge, where we'll basically have like a lot of like prompt tune, like we'll just kind of figure out the best prompts with the best models and then provide those to you. It tends to be pretty performant but very high latency, and the
Mhm.
performance also tends to vary because of the just non-determinism of the system. So this one is basically an ensemble of some rules based, like for profanity is basically an ensemble of a rules based system with the like a small fine-tuned ML
Okay,
model.
that's awesome.
Yeah. All right, I'm going to show a couple of other guards here. So this one is one of the guards that is, purely ML model based, where we basically kind of like have a politeness check. And again, these are all guardrails that I'm basically picking and choosing from the hub and basically just setting up directly. So in this case, it's a model, so you already see, maybe it takes a little bit more latency. Again, very benign kind of like impolite response, but you essentially get like a validation failed, and then you can make sure that everything you're kind of doing you block it and you make sure that it doesn't have these kinds of failures. And then polite bugs, you can kind of do that. You can do kind of the same thing here, where I pick a guard and then I define what is my set of acceptable topics. In this case, maybe my set of acceptable topics is sports only. Again, this is a toy demonstration, but you can imagine that if you were doing something like this, like you're adding this topic guardrails to your entire AI platform at your organization, you can define what are the set of topics that it is not okay for your employees to engage with, like when they're talking to the LLM, or just like maybe unsafe topics, etc. And you can define them, and anytime anybody within your organization engages on those topics, maybe those requests get blocked, etc. And so you can basically configure this how you want it to be. And then so I create this guard, which is basically a topic guard. And then, anytime I talk about, like let's say soccer or sports, it basically like correctly validates that this is about this topic, and again, works like super duper fast and is running a machine learning, like fine-tuned machine learning model under the hood. The final one I'm going to show you is also like our most popular guardrail, which is like PII. And essentially you can PII, personal identifying information. One of the big risks of customers using your LLMs is basically leaking sensitive or private personal identifying information that shouldn't go outside the bounds of your organization. So we provide a bunch of different PII guardrails, different latency and accuracy trade-offs. And we also kind of created our own model here that's really performant, and as part of the index that we launched, our benchmark that is open and ready to be used.
Cool.
And then I'm basically going to show it here. Where if I basically, you can kind of detect what are the kinds of PII, like any email, birthdays, etc. You can basically make sure that they get caught and then they get like filtered before they leave your network boundaries.
One thing I'm curious about when you do that identification, like say a user puts it in there and you do the validation, like how do you think about the UI and the UX for the actual user when they receive that? Because I think that that's actually part of the feedback loop, is telling a user like why this wasn't content that they should be putting into a chat to make it safer, whatever that may be.
Yeah. So I think our approach to this is, again, being like, I think it is hard to be prescriptive here. So what we do is we provide to you from the Guardrails open source framework, like a bunch of different policies that you can set up, right? Which could be maybe you just want to shadow the user, and you just want to log anytime like a risk happens, right? In some database, or in some, like somebody gets notified, but nothing actually happens at the user settings. So for the user, it's really invisible. So you can kind of set that policy. Maybe you can like raise an exception, etc. Where maybe you raise it, like Guardrails will raise an exception for you, and then your overall like front end user facing system will catch that exception, and then like let the user know some message about, hey, according to your company's policies, it's not okay to share this personal identifying information. Try framing your request without it. Or you can basically automatically mask it or fix it. This might not always be possible. Let's say, like if you're talking about like politeness or jailbreaking, right? Like if you're jailbreaking, you probably don't want to.
You don't want to actually, yeah.
Yeah, you don't want to send a request with like a fixed jailbreak. You can like fix it for some of these easier failures, right? Like PII masking, etc. So you can kind of do that. So we provide like a bunch of, I think we have like 6 policies or something, and then it's all part of like the Guardrails framework. So it raises an exception, or it'll kind of like flag when one of those policies is coming through, and then you can handle it on the software side with like how you set it up.
And I guess like that's an interesting question too. Like out of the box hub that you have you put any of these like output templates for organizations to be like, here's how you should handle it based on that yet? Or is it still like evolving on how organizations want to do any of the
I
output?
think we don't have it on the hub, but this is something that we do when we work with organizations.
I
Like
see. Okay.
tell them about like common frameworks and other things we see about like our organizations typically like instrument this. Yeah.
Cool.
Awesome. There's a couple of others. I guess the jailbreaking one is always like interesting. So this is the one that I'm going to show you. And then you can basically kind of like see, like, let's say like these are basically DAN attacks, which are like a pretty like a common kind of attack system, which is like do anything now. And in the early days of ChatGPT, especially, it was kind of weird how effective like Dan was. Like you'd get detailed recipes about like how to build a bomb, etc. And then you can basically kind of like get some of those like outputs to get flagged essentially. This is another one which is kind of like one of those like custom guardrails and stuff. I'm actually going to skip over this just in the interest of time, but this is one where it basically checks for like competitors. And I think the specific thing I want to show you is like you can essentially like when you're doing this on an organization level or an entire like application level, right? Like you typically want to pick and choose like multiple of these validators that all run in parallel and kind of flag when any one of these risks is coming through, not just like one by one. So that's
Yeah.
the idea of what a guard is, which is a collection of these guardrails. So at the end of it, we run kind of like this whole guard, which kind of like runs all of these kind of like tests in parallel. These like with these like multiple kind of like requests that I kind of pass, and then checks like when any one of them fails, like the guard kind of like handles it appropriately, basically. Yeah.
Hmm. That makes sense. And in situations like that, like, do you run in parallel and only like return the response when they're all complete? Like, do you have like ability to like kind of parallel or sequentially do the guards? Like, how does that work?
Yeah. We execute them in parallel. We
Okay.
have so your latency will be the latency of the slowest guardrail. Like some of
Mm-hmm.
these guardrails are pretty fast, and then you get them slow. But like let's say you use like one very very bulky hallucination guardrail, which is like LM as a judge base, then you like it doesn't matter if your PII is really fast, you'll end up getting it whenever the hallucination guardrail is done. Yeah.
Got it. That makes sense. Super cool.
Mhm. Yeah. Yeah. Awesome. So this was about the Guardrails OSS, and you can pip install this, set up your guard pretty fast, and then you end up kind of setting up a server where every request that passes through that server again is guardrail validated, etc. Yeah.
Cool. That's great.
Awesome. I have one more demo to show you guys for our
Let's
second
do it.
product. Should I? Okay. Let me switch over to that. All right. So this demo is going to be about Snow Globe, which is our newest product launched actually pretty recently, 3 weeks ago. And Snow Globe, what it does is it basically, helps you simulate a lot of different users coming to your system and interacting with it before you go into production. So these are simulated, interactions.
Mhm.
And because you're doing this like programmatically and systematically, you can essentially identify where the vulnerabilities, risks, poor performance, etc., in your system is in simulation before you go out into production, right? And the idea is because, like, typically when you would test your AI agents or your AI chatbots, you would only test on, hand selected examples, maybe like 50 to 100 examples, right? That represent your most common users. But when you actually go out into production with an AI system, you suddenly get hit with like hundreds of thousands of like wildly different, questions, responses, prompts, etc. And it's very hard to, understand how your system would kind of do on that. So simulation testing allows you to catch those like corner cases, edge cases, etc. before you go out into production.
Super cool. This maybe
And
begs an interesting question, but to find those edge cases, like how did you think about like data gathering and training some of the models to do the simulations?
yeah, so this is I think this is actually pretty challenging. It's pretty challenging to do this kind of like like from a pure model perspective. You need like a broader system around it that's able to kind of like think about like, okay, what does your normal usage look like? What is general like with how people interact with chatbots, like what does that kind of usage looks like, and then kind of like
Mhm.
go on from there. And then what this is what we build like Snow Globe for, where the idea is that you can run a lot of these kinds of simulations by yourselves without needing to like orchestrate it, because it's pretty like technically challenging thing to do.
Yeah.
Yeah. Awesome. So I am going to show you simulations on this one chatbot I created called Life Coach GPT. So it's basically it's a mental health life coaching GPT chatbot, and I basically built this. It's a for the purposes of a demo, a very very simple chatbot that I built that essentially just uses a system prompt along with using like one of those GPT models. So in order to do simulations, the only things I really need are a live connection to the agent or the chatbot that I'm testing. And once I have that, then the second thing I need is, a text description of what my chatbot is. So in this case, Luna is an AI life coach designed to help users navigate personal challenges. And then,
Mhm.
so what the chatbot is, who are the typical users of the chatbot, and what are the kind of like use cases, etc. I can follow. So a couple of sentences, doesn't have to be massively prompt engineered. Once I have those two necessary kind of like things about my AI chatbot provided to Snow Globe, I can then optionally connect a knowledge base, something that Luna will have access to, or this chatbot will have access to before it's kind of responding, and any kind of historical data, right? In this case, like both of these are optional. So for the purpose of the demo, I'm not going to show it, but if you have them, you can add them, and that makes the simulation grounded in the actual example that you're kind of like
Sure.
actual application that you're testing. And then this is what the process of kicking off a simulation looks like. Maybe I just want to simulate, the wide variety of like just normal users coming and testing my system. So in this case, general users exploring core features and asking common questions. Maybe I want to simulate, users that are only asking questions about, how do I ask my boss for a raise? So you can, simulate like a specific kind of cohort. You can simulate like specific behaviors that these synthetic users have, like maybe they are all trying to jailbreak your system, or maybe they're all kind of getting really really frustrated with like how complex your system is, right? So you can kind of like direct what you want out of your simulation, and then finally you can kind of like figure out how many simulated users you want in your system. Like maybe you want like 50, 20, whatever. I'm going to, like, for the purpose of the demo, kick off a small one, and then how many conversations you want these users to have. So in this case, I'm going to maybe just have like 30 conversations, 6 turns each, etc. There's a bunch of other settings, but I think in the interest of time, we're going to skip that. And then once you kick off the simulation, we start by generating a bunch of these synthetic personas that come in and interact with your system. So this first one, for example, is, an authenticity seeking overthinker. So there's a quiet thinker that jokes when things get too real, and is very tentative, is very hesitant, right? So maybe they keep like kind of undercutting what they're saying. They write in like short bits, skip extra punctuation, etc. Their use cases or their topics of interest are career uncertainty, relationship patterns, creative blocks, etc. And then their style is very tentative, self-deprecating, questions wrapped in polite hedging, etc. Right? So this is maybe like one of the set of users. I approve this, and it looks like this is the only user that's available right now. And then once I approve these synthetic users, these are just 2 out of the 10 that we selected. So more will kind of like continue to come through, as I kind of like do this. But very soon, you're going to kind of start being able to see a bunch of these simulated back and forth conversations happening where Snow Globe is pretending to be the user, and we are just kind of like getting responses from Life Code GPT, which is maybe a system or a chatbot that you might have created, right? And then you can continue having this conversation kind of back and forth. So it takes a little bit of time to kind of like start happening. While this kind of comes through, maybe I'll show you, one simulation, like a larger simulation that I ran. So this is takes about 30 minutes, but like once the simulation is fully completed, like in this case, I had like 25 simulated users, with lots of different personas, lots of different kind of like use cases, etc. How they talk, how they, what their use cases are. Sometimes they're challenging, sometimes they're asking questions, having a lot of these conversations, and you can kind of like walk through these conversations about,
That's super fascinating.
yeah, and I think if you think about it, this is like a very scalable way to get a lot of like data about how your expected users are going to interact with your system, and you can just generate this at scale very cheaply using how great reasoning models are today, and then you end up getting data for fine tuning your model, data for optimizing your prompts, data for QAing, etc. So we kind of built it to close that gap. Yeah.
That's really cool. And, as you think about where this is going right now, I mean, I imagine for multi-agent systems or even like more complex applications, this becomes more and more important for these types of simulations as well, right?
Yeah, absolutely. I think like the more complex the system gets, like I think the entire problem that we're trying to solve with Snow Globe is like I think we're suddenly like, what's the input distribution for a coding agent, right? Like, what's the
Hmm.
distribution of like coding repos? Like, it's so hard to kind of like compute that. And traditionally in AI, you would like kind of work on the distribution, right? Like you'd think about like in distribution, out of distribution. You'd construct a data set that thought about the distribution and try to get representation for coding agents or for any of these like complex AI tasks, which is how AI works today, is just so hard to do that well. So simulation is a way to kind of solve that problem by generating, just like in the wild examples at scale, but like before you go into production, so without actually impacting your real users. So that ends up, like being a very, very powerful tool. And again, very inspired from self-driving and how we kind of solve this problem in self-driving as well. Yeah.
I love it. Maybe just with a few minutes left, would love, any last minute tips or tricks on how to use Snow Globe or the Guardrails tools itself, and
Yeah.
also just, yeah, how should users think about this?
Yeah. So I think like I guess to start out with, like the things I'll say, like the one thing I'll say is like both Snow Globe and Guardrails are, they're generally available. So for Guardrails, you can, pip install Guardrails. It's also open source, so you can fully, get started with it, start using it. Snow Globe is generally available. Just with how complex the system is, we couldn't make it open source and still can't deliver the experience we wanted. But you can sign up and start kicking off a lot of these simulations that I was showing you, even today, right now. The other thing I want to talk about is like where to use what.
Yeah,
So,
exactly.
so Snow Globe is, it's a very helpful tool for helping you either optimize the AI chatbot or AI system you've built, or test the system that you built, right? So it basically is a way to kind of like generate data at scale. If you're fine tuning your models, if you're prompt optimizing your models using any like DSPy like frameworks, etc., having Snow Globe get a lot of diverse data for you is a very helpful tool, so that you're not optimizing on just a small set of use cases, but a very wide variety of use cases, which is much more representative and real, right? Once you've
Mhm.
optimized your system, then you can test it also using Snow Globe to generate maybe like some adversarial users, some like normal users, some auto distribution users, etc. And you can guide it and then test your system by generating a lot of eval or QA data. And then, so this is all like pre-production development test. And then once you actually go into post-production, now you actually understand what parts of your system are vulnerable and what parts of your system are actually very robust, right? So you can pick and choose what guardrails you want to add to your system based on what are actual real risks of your system, and not just, throwing the kitchen sink at something, or just, doing a checklist like thing, right? So guardrails kind of comes in at that post-production kind of last line of defense, side of the life cycle. Yeah.
That makes sense. Super cool. And maybe just the last few words, like any thoughts for the community, broadly speaking, like how can they find you? How can they engage with Guardrails today? And any takeaways that you want folks to take away from today's stream?
Yeah, I think there's a lot of like cool ways to like we're present in a lot of different ways. So check out our website, guardrailsai.com, and it has a bunch of different links for connecting with us on Discord. We have a Discord community of I think 2,000 people or so. You can reach out to us. You can connect with me on LinkedIn, on Twitter. My name is Shreya Rajpal, and if you look it up on either of those, you'll kind of find it. You can also like email us or get in touch with us. At like our company emos, which is contact@guardrailsai.com, and find us there.
Awesome. Well, thank you so much for today, and appreciate all of the demos and just kind of diving into building responsible and also just reliable AI systems. So,
Mm.
pleasure for everyone. Thanks for tuning in, and we'll catch you next Friday on Open Source Fridays here at GitHub. Thanks so much. Take
Yeah.
care, everyone.
Thanks, Kevin.
Thanks, Rhea.
Thanks, everybody.
Bye.
I see it, I want it, I get it.